Assalamu alaikum warahmatullahi wabarakatuh. My name is Mohammed Al-Aqil. Today I'll walk you through the VRF service chaining project. On the left, we can see our designs here, the distributed designs as D0 and D2B, and the centralized design as D1 and D2A. Each is separated by firewall or not. On D2A and D2B, we have our firewalls, while in D0 and D1, we have isolated and shared services with no firewall. Let's start with D0. If we run the simulation here, we can see that each tenant is sending their packet to their dedicated services. No tenant can reach two services because of the isolation that we implemented. This will help us with the fail of services. If we inject one failure to our service, we see that only tenant 1 has lost their packets, while other tenants can continue sending their packets. Now, if we recover all the network, what's considered an advantage of this design is the latency, because we can see on the right the DNS latency P50 at 1.2 milliseconds. That's because each client has his own server that's dedicated to him. Now, if we stop the service, let's clear the event log and let's trace it so we can see the exact route of our packets. We can see that at tenant 4, it goes only to service number 4. So it passes through the switches, the routers, and end up in its dedicated service. Unlike other designs, we can move on to D1, where we have one service where all the tenants share the same service. If we trace route, we notice that all tenants will end up at the same shared service. The advantage of such design is that we can upgrade and do the modifications on one service only. No need to go to each service and update it. We can see if we run the network, the latency will be much higher than D0 because they share the same service. So the load will be heavy on this service. Now, if we test the failure of service, we see that all the network will be down because no tenant can reach the shared service. Unlike D0, where we lose one VRF, in D1 we will lose everything. Now let's recover the network and see more secure and robust design for D1, which is D2A. In D2A, we can see the same design, but we implemented a firewall in the middle. If we stop the network, clear the event log, and do a quick trace route, we see that each service has to go through the firewall to get to the shared service. This will introduce a firewall tax. So we can see the latency is much higher than D1 design, but it is more robust in terms of security. But this introduces another single point of failure, the firewall. So if we run the network again and fail the service, this is expected to be the same result as D1. All the network will be down. But let's recover everything, run it again. And we can see if we fail the firewall, it will result in the same thing. So it is more robust in terms of security, but we introduce another single point of failure. Now, if we recover everything and move on to D2B, this is a similar design to D0, but we also introduced a firewall. If we again stop the network and clear let's do a quick trace route. It is true that each tenant have his own dedicated service. We can see tenant 3 will go to service 3 or server 3, but each of these tenants will have to go through the same firewall to introduce more secure design. Now, we still have the benefit of having multiple services, this will be much faster than D2A design because we have dedicated servers for our tenants, but we also introduced a single point of failure in the firewall. So if we fail the firewall, the network will go down as well. So we will lose all the packets. The the blast radius will be at 100% because we lost everything. This was a quick demo for the design and topology of each. Now we will see how they scale up. Let's stop the network. Now if we scale up our network to more than 6 nodes and run it, we can see that the more tenant you add, the more servers you will add. This will result in a slight increase in latency because we will utilize the router even more. But in this design, if we scale up, it will be much faster than the others because each tenant you add, you will add their dedicated server. Now, if we move on to D1, with the increase of node, the shared service will be at much higher load. So this will increase the latency much exponential than D0. The same goes for D2A because we have the firewall in the middle, which will handle all the added tenants, and the shared service will also handle all the added tenants. But in D2B, it will be faster than D2A and D1, sorry, because we have dedicated servers that we will add for each tenant, but still the firewall will have to handle multiple tenants at a time. This has been the demo for the VRF service chaining and our finding. Thank you.
Mohammed, as you can see, this is the 4 different design for our project. In each design, we use the T01 Linux client as the measurement host for each design. From that client, we tested every services type used in the project: ICMP, reachability, DNS on port 53, HTTP on port 80, authentication through the authentication endpoint, and syslog on port 514, and bulk TCP reachability on port 5201. For D0, the T01 client reaches the local server services from D0T01 server at 10.1.0.130. This proof that distributed VRF services are reachable locally. For D1, the T01 client reaches the centralized shared services server on D1 shared server at 10.255.0.10. This proves that the route leak shared service model is working. For D2A, the T01 client reaches the centralized shared server using the IP 10.255.0.10 through the firewall. This proves that the service chaining through the firewall is working. For D2B, the T01 client reaches its local service server services at 10.0.0.130 through the firewall. This proves that distributed services with firewall instruction are working. Now we will test the blast radius for D0. As you can see, all is reachable, and when another server goes down, nothing is affected to the first client. It's only affected when its own server goes down. As you can see, all services now is down. For D1, As you can see, when we test it, we can reach all services, and when all services can be reached from all clients. As you can see, all services are reached. When we turn off the server, all clients are down and all services are down and can't be reached. And for D2A, we test the same, but there is something, a bottleneck in this design, which is the firewall, which organizes the traffic, but at the same time, when the firewall goes down, all services are down as well. Now, as we can see, we test reachability for the network. All is reachable. We can ping from the second client. Everything is reachable, but when the firewall goes down, all services are down. As you can see, we can't reach the server. Same for all services are down. Same thing for D2B. When we test it first, all services are reached. As you can see, we can reach all services. When another server is down, our client is not affected, only this client is affected. But when the firewall is down, all clients are affected. We can't reach any services. As you can see, all is down. And all measurements are registered and read by the Zabbix server. Thank you.